Привет. Меня зовут Себастиан. Я работаю в качестве евангелиста программного обеспечения для IBM. And я учу русский, но я еще плохо говорю, so I will talk in English. I hope that is okay. And yes, in this talk, I want to tell you how to do tests that spark flow, tests that are enjoyable for enterprise testing. And we will go through a few things. So I would actually just start to share my slides, if that's okay. Then we will see about, that's about me, but that's not that interesting, just a few titles. And what I want to start with is to just show you an application, an enterprise application that we will then kind of test. And if you have any questions during the show, you can just ask some questions. We will then pause and answer the questions together with our expert. And we also have some polls available for you. And then it's hopefully a little bit interactive. And also about myself, lubię coffee. So I like coffee. So we have actually a coffee shop application as our test application. And for the application and for the test, you will get all of the code afterwards, so you can try it out yourself. And for what I will show you, and this is, I think, already a very important thing, is that on a lot of presentations and blog posts that you read, a lot of the examples are always very simple, right? It's like hello world like examples, and then for testing, it makes a big difference, right? You probably notice if you're a tester or if you're a software developer, if you have a lot of use cases, if you have a lot of test data to manage, it becomes more and more complex. And it actually makes sense to think of the concepts that we do. So in this case, what you see here, my ASCII art diagram, this is the application. So we have some coffee shop application that uses some persistence, right? So we have some database that already makes it a little bit more complex. And our user goes and then, we'll order some coffee, right? So imagine a coffee shop, and then we order some coffee here. And then also what we have to make it more, interactive and more interesting, we have a backend. It's called barista, right? Like the friendly person who brews your coffee. And this communication is done asynchronously. So when we order a coffee, then later on it will be asynchronously submitted to the barista. And that is already, a little bit more interesting. Now I want to show you the code a little bit. And walk you through the application. So I like to do live demos and live code and live testing. So I hope that's fun to watch. And what I use this technology that is called Quarkus. So this is what I want to show you. If you have a Java background or enterprise Java background, then you might see a lot of familiar things. But if you don't use enterprise Java or don't use Java at all, or maybe you're on the testing side, I hope it's also interesting to look at it from a code level and abstraction level perspective. So that's not really about the technology. The principles that I'm showing you is applicable for any other things as well, but this is what I'm using. So I have a project here. I use Maven to build my project. With Gradle would be very similar. And this is a coffee shop project where I use this Quarkus, and I use Java 14 already. So this is how I built my application, and this is the main application, this coffee shop that we want to test here. So that is the idea. And then also we have a second, the barista application, but we don't care about it. For us, the barista is just like a backend that we use and that our first application consumes. All right, then what I want to do, I want to show you it in action right now. So that what I have is I can run this example locally using Docker. So what I have actually 3 Docker containers now that run in my coffee shop, one container actually for the database and the barista. So you see, I can already test this out locally. If I say Docker PS, then I have 3 containers running, a coffee shop, a barista, and a Postgres for my database. And then this will be available for a local host. So I just want to show you now how I can try this out locally, and it will be very similar later on. So we have already our full test environment locally with the running running application that we developed. And then if I say I want to go to curl localhost, then I can already access my application and see, okay, this is up and running. It has some JSON response here. I can also have a look at some health check. So now it is up and running. And then for the coffee orders, so I want to order some coffee. I want to go and have some coffee later. I quickly want to show you and walk you through the code, what we're doing here. So again, if you're not a Java developer, it does not matter this much. So that is now this Quarkus specific code here with Enterprise Java. But you just have to get the idea what the application is doing, right? We want to test it later on from the outside and from the code level. And this is then what we will have. So that's an orders resource. So we will have something like, that is an HTTP mapping, a RESTful resource, something like /orders in our HTTP request. And then we can have, you see it here, we have some JSON output and input where we have our methods to list all the coffee orders that are in the system, or update some orders, or create some new order. And this is what we're interested in. We actually want to create some order. And let's just quickly have a look through that's our business logic, this coffee shop class here. So this is a CDI class that is just injected. So you see this declarative programming model with the annotations here in Java. So coffee shop, and then it says, okay, create order. It doesn't do much. It just, well, saves it in the database, and that's it. So that's pretty much it. And now let's do this in the code. So we go to /orders, and that does a get. And the get, well, doesn't do much. It just says, okay, 200, okay. And there's no order in the system yet. So if we want to change it, if we want to create a coffee order, basically what you saw in the diagram, we're now the user. We're using our application to create a new coffee and see what's happening. Then we can say, okay, well, I'm going to post some JSON. So post content type JSON with some JSON object. And then I say, okay, please post a coffee order with some espresso. And the espresso also comes from somewhere, for example, from coffee beans from Colombia. So this is this coffee domain here. If I have a look at the order, what it does, a coffee order has a type. So that's an enum, like an espresso and whatever you can order. Then it has an origin where the order comes from. So that's like a country. So in the, in better coffee shops, you can sometimes select where your coffee beans should come from. And let's do this. And then if I now fire this up, we say 201 created, and then we have, hopefully, the order in our system. All right, so that's good news. The order is here. You can say, okay, origin Colombia. You can also go to it directly, and then we see, hopefully, the status and the type. So it's an espresso and so on and so forth. And it already says, okay, the order is collected. So this means the status update for our domain is done with this asynchronous communication with the barista. So if I create another coffee order, and if I'm fast enough and say, okay, at first the coffee would be preparing, then it's finished. And then afterwards, if I ask again after some time, it's collected. So there is an asynchronous process happening in the background that submits it to the barista and it gets it back. I can do it again. If I'm fast enough, I can say, okay, finished, and then collected. So we see that that what is going on, and this, that it works. So that is somewhat the very simple logic that we want to test, or that we want to verify, that involves our persistence and some communication. Now, the interesting thing is, how do we test this best, right? So I showed you the code here, and what I did sort of a manual testing, right? I just tried it out using the command line. But what I want to have instead, of course, is some test that I can automate, that I can run from code, right? Because here in this case, I just said, okay, post, and then, create this and so on and so forth. But it doesn't tell me whether it's, correct. The next time I change something, I would have to run this manual test again. So I hope you agree that we want to have like a proper test here. And what I will show you first is a system test. I call these, so, there's always a debate how to call these type of tests and how the different scopes, what's a good name for them. So system test is for me or in the projects that I'm in, to test an application or a system where it's deployed. So the actual deployed application, either including some external systems or excluding some systems. So I could say a system test here includes all of these three, or maybe only these two, my application and the database, and the external thing could be mocked or just simulated. In this case, I just want to go and say, okay, I want to test only my application. So I created a test that I call create order naive test, because you will see that's maybe not the best way, but we will have a look into this. And that's probably one of the most important takeaways of this talk, how to structure these tests. So again, that is Java, and that is in this case JUnit 5, but it doesn't really matter. It's more about the approach. This test project here, that's the system test project. I have to separate it. And this project could use any technology, right? You could write bash scripts and fire up curl and then test whether they're correct, or you could use Python or any other language. I typically tend to say it makes sense to use the same language that you use in a production code as well, because your developers are familiar with it. Now, if I go and say, and I've seen many system tests like this, if I say, okay, create verify order, what I want to do, like I did in the command line, I want to create a coffee order and see whether it's correct, right? I want to create it in the system, and then I see whether my system behaves correctly, whether it stores it in a database, whether it goes to the external system, and so on and so forth. So what I do, I say, okay, first of all, new order. New order now it's also a Java class, but it's different to the production class. It has nothing to do with the production class. It's a simpler, representation without proper types. That's okay in the test. And I can say, okay, then, what do I need to do? Well, you saw it. I need to, post something, HTTP post to this resource, and then I have a JSON with this structure and so on and so forth, right? So I go and say, okay, create JSON. We go down there and create the JSON here, type origin, and so on and so forth. And then we say, this is now JAX-REST. That's an HTTP client. So, just some HTTP client utility, or you can use Apache client or whatever. Say post, right, this JSON, and then, okay, assert whether it was successful, right? So I want to see the successful HTTP response, and so on and so forth. I then want to get the location. And then what I want to do, I want to go and test whether it's loaded correctly, or persisted correctly. So I go to the resource, say HTTP get, and get this back. And then I assert, okay, do the all of the information, are they equal to the type and the origin that we had before, and things like this. All right, so if you look into this, you probably have seen, test code like this, right? You have something like a system test scenario, or if you're a tester, you created some scenario where you describe on a very detailed way what the system needs to do or what the test needs to verify. And well, now I can't ask you a question whether you think it's a good idea, but I don't know if that is the best idea to write the tests like this. I've seen many tests like that, but basically what it says, it has a lot of low-level detail, or the method, it's not too long already, just a few lines of code, but I think it doesn't give you an overview what you're doing, because the method does too many things, or it has too many concerns, right? What you should do instead, and let me make some space here. So assuming, and now I want to write something just in pseudocode. So assuming I want to have the same test, and what do I want to verify from a tester perspective? So if you are a tester, then you're probably familiar with this way of thinking. As a developer, I think this helps a lot to, first of all, take a step back and look at the overall business logic and your domain. What do you actually want to test in this scenario? So do you want to have something like, create coffee order, right? Create coffee order, well, with, type espresso, and then something like from Colombia, right? And that's it, right? You don't talk about HTTP, you don't talk about JSON first. So if you look into this code instead, you say, okay, you need to have a JSON, then you need HTTP. You say, okay, if the status is equals this and that, you don't talk about this for now. You say, I want to verify if I can create a coffee order with espresso from Colombia. And then I want to see, well, I want to verify order is in system or something like this, right? And then again, if the order is in the system correctly with espresso from Colombia, right? And then you can say something like, okay, save order ID that you get when you create, and then verify order with order ID or something like that is in the system. On this abstraction level, this is where you should, where you should communicate, where you should talk, where you should create your tests to make it, well, more maintainable and more readable, most of all. So if you then go and implement this in Java, I can show you a little bit better version of this test. That is a test where we actually, well, applied some of the coding practices about clean code, most of it delegation and proper abstraction layers, where we say, okay, actually it does not make sense to cram all of the logic into one method. We just say, okay, create verify coffee order. So what we say, new order espresso Colombia. And then I have a delegate coffee order system, create order from this order. And then what I get back is an identifier, a URI in my case, and then said, okay, coffee order system, now get the order from this identifier. And then say, okay, is it actually, the loaded order, is it equal to the other order? So compare type and origin, and also have a look at all of the orders, the complete order list, whether my order is in that list. And that's it. That's what you should talk about from this abstraction layer. So if you think of it, that's actually the most important thing when crafting proper maintainable and readable tests, not only system tests, but tests in general, to think about abstraction as well. And this is really important because for a test scope, a lot of testers or a lot of developers don't take this too seriously, right? Because it's only test, it's not production code, it's only test. But then you see afterwards what the difference is. Now, if we are interested actually how we create an order or how we load the order or how we get all orders, then I can go and look into this delegate. And this is, very simple. I just say new, no magic. That's just very basic Java. And then I see, okay, this system actually has my HTTP client. It knows about JSON, and it knows about, like which status codes to expect. And this is very important that we separate these lower abstraction details and that we don't have leaky abstractions. Why? First of all, what would happen if I say I go and take this test, Espresso Colombia, or I go and take this test and then say, okay, I want to have a new functionality where I also implement cappuccino, right? Or Ethiopia or a different country, right? So then what happens? Well, you probably know what happens, right? You take the whole test method, you copy paste it, and then say, okay, well, create verify order. And here with cappuccino, right? So this is what we see in projects. And then we say, okay, actually create a cappuccino from here. And then we have to look, okay, what is different again? Well, that's the same, right? And you don't really know what's going on. And you would have to see, okay, where are the lower level details? And now imagine I do this 2 more times, and then you have a lot of copy and pasted code where you don't have any overview. Rather, if you do this, if you say, okay, create order Espresso Colombia, and if your code is very dense and is on a very high abstraction layer, it really makes sense to say, okay, I can take this and I can create a different test scenario, and I can have multiple, scenarios and different permutations what I want to test. And you keep the overview of what you're actually doing. You're not lost in all these details. Because if you have this test, imagine what would happen if you change something in production and you change HTTP for another protocol, right? Or you change JSON to protobuf or to XML or to something else. Then what you can do, you can take these tests and you can throw them away, right? You have to change so many details like here, and so on and so forth. What happens if you introduce proper abstraction layers? Then you say, okay, if actually the underlying communication changes, you don't have to change anything in the scenario. That is like the higher abstraction layer, that gets implemented somewhere. And here you can say, okay, please change, like HTTP for something else and things like that, or, swap the host name or some for all of the tests. And then you don't have to throw away and redo all of your system test scenarios. So this is a very important thing for now. And also what I want to show you now, and we can run this test in a second, is I want to show how now to use the second, the barista system, the external system. So if we have a look into this different or kind of system test scenario, what I have here now is my coffee shop application, a database. And for a system test scenario, I can say, okay, I'm not interested in the barista, right? So I can mock it away. I just assume, very similar to code level tests, I mock something, I assume that it works correctly, and I can swap it with a mock server, wire mock, or something else. And in my system test, I go and, create my coffee. But now you have to say, okay, wait, I also want to verify whether this communication is correct, right? Whether my application talks to the backend correctly. What I can do, very similar to in a code level test, I can go and say, I control and verify my mock. So I say, dear mock, were you called correctly with the correct parameters like I expected, right? And now this is even more important now to craft proper abstraction layers, because what I do in my system test here, I also have a barista system. And what the barista system does in my second test case, I say, okay, dear coffee order system, please create an order. And now I want to see whether my status update transition is correct, right? Like this collected, finished, preparing. And I say, okay, barista system, and it's very similar to Mockito, like when and then. Okay, if you get a request for this order with the ID, please answer this response and say preparing status. So the barista system just responds with status updates, right? It brews a coffee and says, okay, I'm preparing, I'm finished. And then say, okay, if you will be called, then you will respond. And then we know that later on the coffee order will, the system will call it in this way. And then what we have to do, and this is just some routine I wrote here, because it's an asynchronous communication, we don't know when this happens. So we cannot synchronously call it and then we get the result. We don't know if we call it now, if it's done already 1 second later. So we actually just have to wait. I have some, wait for invocation here. And then when it's done, it returns, we say, okay, now load the information and compare it. If now the status is preparing, and then afterwards do the same thing if the status is now finished, and then we check this ping pong status transition. So that's one way how to do it. And if we look into the barista system now, what it does, and this is also now an implementation detail, it goes to the other system and it will assumes that there is some wire mock running. So I use this wire mock technology. So the baristas then will not be the actual barista, but a wire mock container. And I can configure it correctly. So I say, okay, if you will be called with the resources/processes, and then please return the status and answer for the different status, and so on and so forth. And later on, we can say, okay, were you invoked with the correct information, and so on and so forth. So we can verify whether the information is correct, and then we verify this API contract. So this is how we can verify that our application works correctly. All right. So now what I want to do, I want to stop my previous Docker containers, and I want to run a system test environment. So what I do now, I run 3 Docker containers, and I can show you the script. So typically, you can use many ways to start up a local environment. We will talk about this a little bit later. I typically use very basic shell scripts with Docker run, because for me it's actually the easiest thing to set it up locally. You can also do a Docker compose. You can use a few different technologies. I mean, I would say it almost doesn't matter. It matters for how quickly it starts up, but that's just all. And usually I run these 3 containers in my system test. I run it almost the same way, but for the barista, you say Docker run, and the Docker image, it's different. It's not the barista, it says wiremock. So instead of the actual barista, I run a, like Mockito for an HTTP server, and I run it in this way, and then I go and start up my application. So if I now go back and say, okay, go back to the localhost example, I can see, okay, that is, again, up and running. I can check the health check and so on and so forth. And then what I can do, I can actually fire up my system test, right? So now what I want to do, I want to fire up that test and say, okay, from my IDE, for example, I fire this up, and then the test itself will go to the mock, configure the mock appropriately like I need it, and then it will just run these tests. And as you can see, first one is already green. That finished very quickly. So it created it, and then, assuming everything is correct. The second one is now also green. The second one took a little bit longer. So the first one was very quick. The second took like 6 seconds, which I would say is a long time for tests. Why? Because the system test that should run actually very fast, they just connect against something that is already running. So you saw I fired up my test environment locally, and that can run for a longer time. That's the plan. But it took so long because this communication, actually, that's an asynchronous timer, like every 2 seconds or so for each status update. And then you just have to wait for the invocation. And it takes so long because of the business. So that's part of the domain, that it takes a few seconds to brew a coffee. And that's why the test takes a little bit longer here. But it's basically the same thing what I did on the command line now. It's also an idempotent way, so I can run it again. And I can go and verify this. All right. So now there is already some important learning here. So first of all, I want to have a test that runs very, very quickly. So even on a somewhat end-to-end or a system test example, where I have a deployed application here, and then I go with my system test and connect to it, I also want a very fast feedback. Why? Because if we develop modern applications in a maybe microservice architecture, then we don't have a lot of logic in our applications, but the integration becomes more and more important, right? So am I talking with my database correctly? Do I talk to this external system correctly? And I need to verify whether all of this is the case. Later on, we will cover unit tests and some code level tests, but actually it's more important to verify whether the deployed, the production-like application works correctly. And I also, as a developer, I want to do this locally. So then when I push something, I already have tested it, right? It's not like the first time that it runs on a CI/CD server. And the second thing is I want to have fast turnaround times. So I want to have fast feedback. And I said this before a few times, I want to stay in the development flow while I'm coding, and I run my tests, and I want to get immediate feedback that it works. And with these type of tests, it is actually possible, because I can go and say, okay, run the tests, and I can now go and run this, and I can rerun it again. And after 2 seconds in IntelliJ, I get the response, okay, now it's green. And then I change my test, and I could run it again. So there's fast feedback. And also what I did here in this development mode, and I can show you that's actually a feature of Quarkus, and I will later on point you to some resources. So I created, for example, a video how I explain how to run this, because actually what happens, my coffee shop now runs in a development mode. This is a feature of Quarkus, and what it does, it has the connection to my source code, and it listens for changes. So when I make a change here, for example, I go to some root resource, and then this is the /root resource. I can go and go here and say I want to change something there. So build index page, I say change that's a big JSON structure that I create with my hypermedia links. If I say something like hello world, then what I can do, I can go and curl, well, not the health check, but actually the root resource, and say go to the root resource, and then it says, okay, hello world. You see the change, it's immediately there. Or I told you I'm learning Russian, so I can say, wait a second. change the correct keyboard layout. I can say Привет. Нет. Okay, now it's not really easy to type on a Cyrillic keyboard if you've never done this before. Where is it? There it is. Yeah. Привет, world, instead of hello. So you can change the code while you're developing, and then you just wait for the reload, and it reloads very, very quickly, and you already see the change in the running application. So you can change any code that you do, and many technologies nowadays support this, and you can see your changes immediately being reflected. This is different to working on the code level. It really changes the deployed application, like what's running inside here. And now this is really important for a developer while you're developing and testing, to have this type of development workflow, because now I can stay in the flow the whole time. I can just, like change some code here, remove this again, and then I can already try it out either in my browser or on the command line, or I can just say, okay, I just rerun my test and oops, wrong key. And then my test will be re-executed, and I immediately get the feedback, right? So I can change something on the production code, I change something on the test code, and then I already see the changes being reflected. What this does, this Quarkus technology, it runs also in a container. So it actually has it's called colon dev, like Quarkus dev mode. Usually you start it like this, Maven Quarkus dev, so that's a Maven plugin. Now, in my case, this would not work because I need my Docker containers. Why? Because of the database. The database also runs in a container. So what I have just a temporary way of doing this remote dev mode, and that runs, Maven in a container, and I can start this up then. As a developer, what's also pretty cool, this mode, it comes with a debug mode. So actually, I can go to my IDE and say, okay, go to a debug and to do a remote debug via localhost and the remote debug port. And now actually I run my IDE in a debug mode. So if you do some development and then you have a bug that you cannot find out what happens, and that maybe that bug only occurs once you actually deploy your application, right? Once it has some interaction with other things. In this case, you can actually go and say, okay, I have the connection to my code. I go somewhere to, I don't know, this resource or that resource, and say create order. What happens here? I actually want to set a breakpoint. And then if I now rerun something on the command line, or even better, I say, hey, go and re-execute this test. And then I can run this test from the outside of the application. And actually my IDE will go and catch my breakpoint and say, okay, now I'm here, create order, and I can step through and see what's going on. And then just, continue and, step through all of these things. Let's remove this again. And I have the way of debugging my application while I'm developing and while I'm running my system tests. So this is, I think, really, really helpful for just this mode. And again, this is what Quarkus supports, but in general, that can be done with any technology, right? So it's just about the approaches, how you run your local test development locally while you're developing, and how you have ways to basically run this. All right, so for this approach, how to do this locally, I hope that point was already clear, that this is very important to get fast feedback, to stay in this development flow. Again, if you have any questions, please just feel free to ask them anytime. And what I would do then, otherwise, I will just show you how to now deploy this to a more productionized environment, and then how to test it there. So what I have a Kubernetes example, of course. So it's not about Kubernetes, it's just about how to run and then test your application in production or in a production-like environment. If I say, for example, okay, I have some more proxy servers, some DNS configuration, I want to test a more production-like approach, like end-to-end. What I can do, I can, deploy my application, and I can show how to do this in a Kubernetes environment, for example, right? Because I have containers now, and I can go and take the containers to Kubernetes. If you're not really familiar with Kubernetes, it's not about this at all. It just shows how to do it on a, remote environment somewhere in the cloud. And I use a cloud actually. So I have a Kubernetes cluster running in the managed IBM cloud service for managed Kubernetes that runs somewhere in Germany. And if you know about Kubernetes, then you know you can take these kube control command line tools to connect to your cluster and say, okay, give me the cluster info, or give me the running services, kube control, get services, give me the running containers and pods. And now it's an empty cluster, there's nothing running. Let's stop this environment again. And what I have, and again, this is not about Kubernetes, I just want to quickly show you how I deploy this. So I can go and say, okay, I have my production-like environment where I deploy my coffee shop with a specific Docker image. That's the one I built. And I connect to this. And of course, I also have my database and I have my barista. And the nice story is, in a Kubernetes environment similar to Docker, I have this abstraction over the application, so I can swap things out. I can actually go and take my system test environment to Kubernetes and say, maybe I want to have not the correct barista, because otherwise I end up with 20 coffees with 20 drinks, but I want to have like a simulated environment as well. So I can go and say I create a system test deployment where my barista is not the actual barista, but the same wiremark. And I can reuse my same system test. So that's the good news. I create my test scenario once, and then I can reuse them for different stages and different environments. So this is the reason why I write my tests in this way. So what I will do, I say, okay, I have my Kubernetes cluster here, and then I deploy something by saying kube control apply. So I apply some resources and say, not this one, but coffee shop deployment system test. And what it does, it creates a bunch of resources in my cluster. So that's also, the YAML files, infrastructure as code. That's good for us developers. So we save a lot of time managing infrastructure and resources. And then what it will do, it creates 3 pods, a barista, a coffee shop, and a coffee shop DB. And we actually know the barista is not a barista. It is actually the wiremark. And once that is up and running, we can also test it. Now, what I can do, I can go and say curl, well, not localhost, of course, but now a proper IP address of my cluster. And then I say, for example, health. And now, oh, cool. Now I see my coffee shop is up and running actually in my cloud environment. So that is public cloud environment that is running my actual coffee shop. And now I can go and say, take this test and connect it, well, not to localhost, but to my cloud environment. So I can have a look here and say, okay, I can configure this actually. So I can say, instead of doing localhost, I can, swap this with an actual IP, and then it runs the same things against my cluster. And this works because the barista system, that's also a wiremark. So I can configure this as well. I can go to my system test project and saying, okay, verify, and go and change these properties just in the, you can do this in the command line. So this is how you could run it on your CI/CD environment. Do this a little bit later. And then we run our tests. And in this case, status was not successful. Okay, let's see what's going on. We run, oh, yes, the naive test. Because I changed the naive test, that was not intended. I showed you how to copy and paste the test code. That was not a good idea because now actually the test broke. This one. So if I say, well, cappuccino, that doesn't exist yet, right? We can change this actually back to espresso from Colombia. So now we are testing the same thing twice. And then we say, okay, never mind. We just rerun the same test. And now it's actually again running against the Kubernetes cluster. And then we say, okay, this test executes quickly, and our validation test, well, we know this takes a few seconds also on the Kubernetes example. And then we can actually go and say curl in our example again. And if I have a look at the orders, I actually see, well, now there were a lot of examples just created by my system test. And this is already the proper deployed example. So I can go and run this environment in a properly deployed production or production-like environment as well. I can configure some proper DNS names, right? And all these things with certificates that I have to just be closer to production to verify this in this way. And this runs also very quickly, as you saw. And this is the good news for developers to have very fast feedback. For me, that's always important. If you have another environment where actually you want to do some debug as well, what also works, that's even a little bit more crazy, to say you deploy something to Kubernetes that is not the coffee shop, but this remote dev, what I showed you before, like this. You can have a look at this video later on if you're interested in Quarkus, like how you do this remote dev, what I was showing you in my system test script. You can actually deploy this to Kubernetes as well, and because it's a container, and then you can connect to it via remote dev and basically have the hot swap mechanism into Kubernetes. But please only on test environments, right? Because then that's not production ready. But for testing something out where you have an environment where you actually need to validate something that runs in a production-like environment, that's very important. All right, so these were the important things about system tests. So again, for me, the most important takeaway is that we have these tests that run in a very plain and I would say isolated or decoupled test technology. So what I typically do, I try to separate the test runs, the test scenarios from the test environment life cycles. So I don't use a test technology, you know, like Mockito tests or Spring tests or Quarkus tests. Why? They always fire up my application, which originally is good, but for me, it's not that great because it always takes not a long time, but a few seconds to start up, right? If you have a Spring context test or Quarkus or any other test that starts up something like a simulated environment, it always takes a few seconds. And then for me, this is just faster to say separate it. Start up the environment first and keep it running during my development session for minutes and hours. And then I have maybe a hot reload mode of saying, okay, test it quickly, connect to the environment, test it again, redeploy something, test it again. And that works quicker from a turnaround perspective. Now, what I want to do as well, I want to go a little bit down to the code level for these more code level type of tests. So these are now Java scenarios again, but in general, it's more about, the approaches as well. What I want to show you first is another integration test. It's called order smoke IT. This now resides in the production code. So I told you before, I like to separate the production test from a system test project to not accidentally reuse the same classes. It should be separated, like could be different technologies, just test it from the outside. This is now what is called a smoke test, or just an integration test that tests against my application as well. It just quickly says, okay, are you up and running? Is system up? And things like that. What the difference is here, why I'm showing you this, if you use Maven for Java projects, then you're probably familiar with Surefire and Failsafe. These are two ways of running tests. Surefire or unit tests are tests that are always executed if you do a Maven build. And these integration tests, and you see the name IT for integration test, that's a Maven convention. You don't have to configure anything. These tests are not executed if you run your project. So if I say, go to the coffee shop project and then run my Maven verify, for example, or my Maven package, then it will not execute my integration tests, only the Surefire tests. So I can build this here as well. That's the same thing like I did in my IDE, and says, okay, Maven Surefire plugin. No, it's too fast. Here, it will run my tests, and then it goes through them very, very quickly. If I take my integration tests, I run them differently. I say Maven failsafe integration test and then failsafe verify to say, okay, run the integration tests. Now, this will actually run something that connects to my application. Now it fails because there's nothing running anymore. I can actually start it up again. Local run environment or something. And for this reason, I want to separate these life cycles. So usually the integration tests don't run for the normal build. I can run them later on once I deployed something. I can also point them somewhere else. I can say, okay, point it to a different cluster like we had before if I want to, and then I have this separation here. Again, they run very quickly as plain JUnit test. So that is, just a different abstraction level. Once that is up and running, I can go. I hope it's already started, and then I can run them here as well. And as you saw, I can run them from the command line. Yes. I can run from the command line. So we have some question in the show.
Yeah, Sebastian, we have several questions. It's a common question. Alec asking you why you don't use test container, why you use Docker files. It's
yes,
what response from you?
Yeah, that's a very common question. And actually, their test containers is also evolving. So I would say from my perspective, it's getting better. What test containers does, it has a way to tangle your tests with your test environment. So if I go back to say, to go to my test, what a test containers would do, it would annotate your test class with test containers. And then it would, once you fire up your test, it would start up your applications with Docker containers. So under the hood, it wraps Docker Java, and then starts up these from your test. This is very nice for developers because you don't have to start them manually. But for me, this is coupling the environments too much. Why? Because even if you have a very fast technology, it always takes a few seconds to start them up. Now test containers is evolving. It's actually, I would say it's getting better. For example, you can have reusable containers where you start them up once, and then, if they're already running, it keeps it running, so it's faster the second time. But then what you cannot do from my perspective, you still cannot use what I did with the Kubernetes example, that I say, if I reconfigure this to something else, not localhost, I don't even want to, maybe in the second example, I don't even want to start up anything locally. I want to take the same test and just point it to somewhere else and say, okay, now go against Kubernetes. And if you have a class that integrates with test containers or any other technology here already on the class level, then it will always try to start up something where I say, okay, now I don't want it. I just want to reconfigure a different IP, and then, it's there. Now, actually, I think already you can do the same with test containers. There's a way from, and Sergey, one of the committers, is created a blog post about it, like how to start test containers individually from Java, like public static void main. I think that's a very nice approach. This is then very similar to what I do with the scripts, like here. But also, to be honest, then if you have this approach, then it's pretty much similar. Then you can do it and have the same benefits. But for me, to be honest, this is always faster, because I'm also a lot in shell scripts and the command line. And for me, it's faster to say Docker run, Docker run, Docker run, and I'm done. Of course, the integration is nicer. They have, so instead of sleep, you have some proper health checking ways in test containers, or you can use a Docker Compose, which is also a little bit nicer than this. You can write it in YAML. But for me, it's much more important that you have this separation of these environments, that you have the fast turnaround. If then you started up using test containers or using Docker Compose or shell scripts or something else, that's fine. But for me, it needs to be fast. So that's the reason why I'm personally not yet using test containers. I've been playing around with the new way of starting up test containers. I think that's great. That's a really good improvement. But I don't use it in a usual way of running it. I have a different example here that is very similar. That's a Quarkus test. This is very similar to how test containers start or how Spring Boot tests start. And I also didn't use it. I just said, okay, that's how you would do it, but it's too slow to start up, because each and every time now you are starting up a new application. They are trying out something similar like test containers, where you say only start it up if it's not already running. But again, I want the flexibility of saying, okay, which test port or which test IP am I actually testing against? So for me, it's about the flexibility of configuring that. That's why I'm personally not using test containers, or not in this approach. I would. It's fine if you use test containers again in the standalone way.
Okay, thank you for your response. Yeah, we have also another question from Dmitry, but I think we will give answer after our presentation. Okay, let's continue.
Okay, perfect. Yes, so this was a very good question. I get this quite often we will talk about test technology a little bit at the end as well. And with this example, now we had the Kubernetes way. And now what I want to show you is besides these different life cycles, what we just had in the Maven on the code level, I want to show you a little bit how to do code level integration tests, because this is connected with the technology of doing something like this, where we have a Quarkus test, and then actually in your test, and now this is very similar to what you can do with Spring Boot, where you say in your test you can have something like @inject, and then inject a coffee shop, your class, and then say, okay, your class, like do something, and or coffee shop, and then like create order and so on and so forth. So you could quickly inject your code and wire up your code during your test, but for the same reason, like here, I'm not doing that, or I'm not a big fan of that. Why? Because it doesn't run that quickly. If I run my whole test suite here, so if I say all of these tests, run them, and I did it just now before in Maven. So if I go and say, okay, where is it? Like run, and run all of these tests in this package, then it just runs very, very quickly. So that's the same way what I did with Maven Verify. You saw it, it's already finished compiling, and now it's just done, and that's it. And that's the same thing on a code level, that you want very quick feedback. So if I say, and please take, I don't know, like some validator test, and I can go with JUnit. That's, again, just plain JUnit. You can go and have a parameterized test with many, many different input and output, and that just runs very quickly. So if you're a Java developer, or a developer who's familiar with unit testing, that is very much a unit test perspective. But again, I just want to point out that even for unit tests or for code level tests, I'm not using some something like Mockito test runner or Quarkus runner or Spring Boot test runner. Why? It takes too long to wire up all of these things. What I do instead, and so that was the different mode with the development mode. What I do instead, I in my book that I wrote, I called this component tests, or another way, maybe a better name even, would be use case tests. I want to fire up a code level test where I can go through my main use cases and wire up all of the components and still execute it quickly, right? I don't want to start up an application context each and every time because it takes so long, but I want to very quickly verify whether everything works on a code level. So instead of doing this, and again, I have a naive use case test, I basically want to have something like this. I go to my coffee shop. So this is the test code, and this is now the production code. I say production code coffee shop, please create order, right? And now it involves like one class, for example, this entity manager, or it could be like some order processor. So it involves a few delegates, right? If I want to test this on a code level, you probably have seen this, then I have to instantiate this class, this works, and then I have to mock or instantiate, depends, my delegates. And this is a lot of work, right? So that is the reason why these testing frameworks have been created in the first place. If I do it, I now did it in a naive way, manually, I say, like mock this and mock that, and then set this field, and I don't know when, then, and so on and so forth. And again, this is, not really nice code. I say, okay, if you test this method, then you have to verify and do a lot of things by hand. Now, instead of doing this, and again, it's the same takeaway, if I think about proper test code quality, like abstraction layers and delegation, what I should do instead, I say, okay, I actually come up with some delegation here, and this is just a scenario of that's the main my main production code, and that is the test scope. I set up a coffee shop TD for test double and an order processor test double, which already does all of this wiring and preparation logic in plain Java. So that's just using the plain wirings. That's very basic, but thanks to this abstraction, and I encapsulate it in this extra class, I do the logic and efforts only once. So what I can do, I say coffee shop use case test. So that is my test of, like creating an order. And now you see very similar. I have just, a test double, and this test double, it resides in test scope, but it extends the class of the production scope. And it says, okay, just add, a few concerns, like, mock this already and say, okay, set this field, and then verify means, okay, this and this. So I offer more business domain relevant methods that are just relevant for the test scope, of course, but that I can call from a higher abstraction layer. So I don't have to say when, then this, and so on and so forth. I just say answer for my unfinished orders with these orders. And then how it does it, again, that's abstracted away in this lower implementation detail. And in my test, then I just say, and now you see how readable this becomes. I say, okay, coffee order, create order. That's my usual method. And then verify, create order. And the verify already, calls all of the delegates and, delegates it down. Have you been called correctly, and so on and so forth. And same for test unfinished orders. Now it's even here more clear. First, answer for the unfinished orders, then call the actual method, and then, verify. But on a much higher abstraction layer, where I say, okay, verify the correct, domain usage, whether my code has been used correctly. And now if I run this, all of these things run really quickly, and then I have fast feedback.
Sebastian,
have another question.
We have a question. Yes. How much time was spent? How much time you spent on this abstraction? In the beginning of your talk, you told us about abstraction and how you spend time to refactoring your code with abstraction.
That's a good question. Like, how much time does it? I guess how much time does it take to create this abstraction? At first, it creates. So it's basically creating these classes like coffee shop and order processor, like one for the main components in my components or use case tests. Right, I have like a class here for that involves all of the use case of maybe one delegate or two delegates, and for these I create these abstractions. Yes, it is a little bit more effort, but if you have a look into it, these classes are also tiny. They're not very, very big. And you have to do this logic only once, right? Because what usually happens that you create a test, either you do, like a test where it's not that fast, where you say, something like Mockito, and then it's a little bit faster, but you also have to do this when then, right? Same with Spring tests. But if you have these type of tests, then you're copy and pasting this logic all the time, right? At least that's what I see in project. And you have test this, and you copy and paste it, and you have test that. So ultimately, I would say it doesn't take much longer, at least if you have a more complex project, right? In the beginning, it is some extra effort while creating a new class. You say, okay, you create, this class as well. It's not huge, but it's a little bit effort, a few minutes. And but the more complex your project becomes, the more time you save because of this abstraction, right? Because what you do, the more complex your project becomes, the more of these classes and test cases you have, right? You have test create order with different details, test create order with espresso, and this then becomes more manageable and actually faster to create because you create it on a higher abstraction level. Once you can use and reuse these abstraction components, then it saves you time and effort. And in the same way, like with system tests, it makes it more maintainable and it makes it more readable. If you read through it, create order, verify, okay, like you can comprehend it quite quickly. So about the time, I would say it definitely saves you over time. In the beginning, it's not much, right? Like for a class, this is the test doable for coffee shop. Have a look into the order processor test doable, like same size. So it's not that much of an effort. It's more about comprehending this, the importance of creating delegates and creating abstraction layers.
Okay. I also, do you hear me? Yeah.
Yeah.
Okay. I also have a question from me. For example, if I have some tests that I need to do very quick, and what my first step? I need to make abstraction for my next test, or I can first point I write my test, or after that I'm refactoring it with abstraction. What do you suggest?
Oh, for the approach, yeah. At first, I would always just write it. In general, like with tests, with code quality, also for production code, I would also write, the very straightforward example at first. Like write all of this logic, just write it down. And once you see all of these delegation layers, then I would just delegate it down, right? So do it directly first, and then to say, okay, now I can create a delegation package from this block and from that block because it makes more sense. And then, just go down deeper. What I personally mostly do is I start with a test class, and then I say, okay, I just create the few lines of code of the logic here. And then at first, if I see some pattern, I create a private method first in the same class. And then either if I have another test case that does the same thing, or if it becomes too complex for one class, then I create a delegate out of it. So I do it from a very iterative approach, because I think that's just more, it gets you to the point faster than thinking about the proper abstraction first. The same for production code. If I see people, who spend hours of thinking, making the abstraction perfect before they write the first line of code, then at the end it probably will change anyway. And, you just, I would say you're more pragmatic if you just start right away. And then once you see, okay, now it happens here, and then I just create a lower level abstraction out of it. So this would be my approach.
Yeah, okay, thank you. And also we have a question from Pavel. He asked you why you personally prefer Quarkus to Spring.
Oh, why I'm preferring Quarkus to Spring? Okay, that's a different question. What is very nice about a Quarkus is that what it does a build time optimization for when you do the Maven build. It creates, actually gets rid of all of the magic, all of the annotations, and all of the inversion of control that happens. So if you go to the website, it will tell you, like a comparison with if you just run it in a Java way compared to like traditional, which is, Spring Boot, for example. You have like a big saving in resource consumption and also in startup time. Why? Because it has some effort when you do the Maven build, and it goes through your project, and all of the logic that usually your runtime would do, right? Spring Boot is very similar to to other enterprise runtimes. Once you start your application, it looks at all of the annotations in your classes, it scans through your whole project, it builds up together all of the components, like Spring Services, Spring Component, and wires them together. All of the enterprise technologies basically do the same, but what Quarkus does, it does all of that at build time already. So once it created your created jar file, your artifact, then this is already pretty small, and it only contains basically the actual invocations. It does not use reflection, and it does not use like any other magic here. And also what's very nice, because of this, you can actually further deploy, compile it down to a native executable. So I can say I use Graal VM and Substrate VM, which is a project for using Java as an executable binary, like in binary on the Linux, for example, that it can just very quickly start up. This is even smaller, and it starts up really, really quick because it doesn't have the JVM overhead, and it's basically different technology. But this only works because of Quarkus's build-time optimization. So this is pretty much a new feature, which Spring doesn't have for now. And I think in general, Quarkus is just a very interesting technology. Also, for me, it is based on enterprise Java APIs. So I also use, Liberty a lot, which is a different, also modern enterprise runtime. And it has all of these, like JAX-RS and CDI support, what I showed you with this. So these are JAX-RS annotations, these here. And then we have, CDI for injection at inject, and my coffee shop with the application scoped and things like that. So it depends a little bit, but that is more, up to taste which APIs you're more familiar with. But Quarkus especially has this extra benefit of your resource consumption and startup time, and also this development mode like Quarkus Dev, which is very nice. So the whole development experience is really, really nice to do in it. And once you get used to it, you will, I think as a developer, you will enjoy it a lot. So that's why I want to raise awareness of this technology.
Okay, let's continue.
Then we just continue with that. So what I showed before about these use case tests and test tools, so it's basically the same talk again, to care about like proper abstraction layers and proper delegation, because it will save you time, right? And then actually what for me the benefit of this approach is I can run my tests again without any test technology. So the same reason what I said before, why I don't use any other test runners, here it's the same, it's plain JUnit, and these things I can run just very, very quickly, and also on a code level while I'm developing, before I even start up my application, it just gives me very, very fast feedback. I don't have to start up anything here. From my perspective, this is just very nice to use. So that's basically, the most important thing from a code level test perspective. In a similar way, I don't use really like Spring context tests or, Quarkus tests, or in the Java EE world, there's a Killian, because for me that is just like the wrong layer of running it, or it takes too long, first of all, and second, it's not a properly deployed application either, right? So I have to have another stage where it deploys it to a production-like environment anyway, and then it's just extra effort that I do. What I have here, just to give you an idea how I like to set up a productive development workflow for developers who do testing, or even for some testers, where we say, okay, I want to have like two different versions. First of all, local development while I'm developing locally and before I do a git push, because I want to verify that everything works before I do a git push, because otherwise my pipeline fails, and then all of my colleagues tell me, hey, what happened? You broke the build and you disturbed somebody by having these notifications. So I want to make sure that everything works locally as well. So typically what you do, build and then unit test for, this is what I did in the coffee shop. So this is basically the equivalent to what I did with Maven package or Maven verify. You just build your project and you very quickly run your unit tests. And this should run in, like few seconds. Now the Quarkus build, this takes a long time, so it's like 9 seconds, but typically, just the unit test should be within 1 second or something. JUnit is very, very fast, plain JUnit. Then what it can do, you should deploy it locally, or if you have the chance, it really, really makes sense to have some local development set up. Either it's via Docker, or, we talked about it, Docker Compose, test containers if you want, any way to deploy this thing locally, ideally in a development mode. What I showed you with the system tests, where you have something that runs and you don't have to redeploy all the time. So you make a code change, and then what I did with Hello World, you can just see the change being reflected immediately. That's really helpful. And then what I usually do is like some basic integration tests, like what I did with my with Maven integration tests. I don't know if it's still running, and they run also very quickly because they just connect to something that's already up and running. Now I do this on the command line. Of course, you can start them up in your IDE. And then locally, also, I want like a system test. This is what I showed you in the beginning with some, like system test project, where you say, please test the proper workflow of creating a coffee, checking at the barista backend, looking into my database whether it's correct, and all of these flows also locally, if that works. If I involve too many systems, then what I can do locally is I can mock systems like I did with my barista. If that's not enough as well, then I can have a proper system test environment, like on Kubernetes or somewhere deployed. And then I have a dedicated environment for me where I can do this remote dev, for example, or have some ways how I can test and change the code quickly. So where I can swap the code quickly just for this quick development turnaround. So that's really important. On a CI/CD environment, what then I would typically do, that's just one example, but in a somewhat similar way, you would say, okay, build that project unit test. They also should run in the same way. Now you do a similar thing like deploy, for example, on Kubernetes. So you could have this example, what I showed, deploying to Kubernetes, and then run your same tests. And this is now the important thing, that I don't want to have this extra effort. I just take the same tests, because I separated the lifecycle, and just point them to somewhere else. Just configure it to say, okay, now take this IP, not localhost, but the other IP, and then a system test as well, not localhost, but other IP. I can rerun my same test scenarios and just have this, like way of interacting. And I think this really makes sense, and it's a somewhat, very pragmatic and especially effective way of testing. And then as some key takeaways in general, and we'll talk a little bit about like test technology and test frameworks. I think it's very important that the test code quality, it matters. So it's not just a nice to have that we say, okay, we have not only proper production code quality that we usually as developers always care about, but the test code quality is really, really important, especially with regards to delegation and abstractions, so that we can somewhat create reusable test components, and just to make our test more maintainable and more readable. very important, we covered this a few times, that we have fast feedback and fast turnaround cycles so that we really stay in this development flow mode. And I think a prerequisite of it is to somewhat look at the test life cycles from test and test environment and separate those life cycles. To say, okay, I can set up my environment. This takes a few seconds, like Docker run, 10, 30 seconds, that's fine. But then I want to be fast while I'm developing. Reusable test scenarios, also idempotent, is what I briefly showed you. So if you have a test scenario that doesn't rely on a pre-computed state or something like that, on a pre-existing state like in your database, because typically your users do the same thing. They just go to your application and connect to it. And about, yes, test frameworks. So I think, or I claim, that your test code quality and all of these abstraction layers and proper delegation are far more important than which test framework or which test technology you choose. Why? Because in this test, or in my system test that I showed you, plain JUnit, nothing else, you could say, okay, hey, I like, Spock testing or Scala test or some other things. Then I say, okay, it's fine, you can use it. That's fine for me, of course. The reason why I don't do it is, I would say, creating these proper delegates, this delegation, these abstraction layers, or in my coffee shop test here, no, not this one, create order test, these delegates here, this is far more important, especially once your project becomes more and more complex, right? Because the logic down here will grow much, much more complex, and that ratio is much bigger than, the tiny extra syntactical sugar that you get by using another test technology. And typically a test technology is a little bit more to configure in your build, like if you otherwise don't use Groovy or Scala, then you have to extra just add it. It really depends on your project. And it typically also runs a little bit slower than just plain JUnit. And for me, that's a killer feature. JUnit, super fast, or any other equivalent of a very basic test technology, that is just really convenient. I use mostly JUnit with Mockito if I need it. Assert.j, that's a very nice certain. So if we talk about Java, of course, and with any other technology, equivalent that just runs very quickly. There's another thing that I want to just point to with regards to testers as well, and creating test scenarios. So one thing I found useful sometimes was a syntax like, BDD testing, and especially human readable syntax. So something like this. This is Cucumber test with a Gherkin syntax, where I say, okay, validate this feature of, validating coffee orders, or I have some other example. So creating a valid coffee order. When I create a coffee with espresso from Colombia, then it should be accepted. When I create espresso from Germany, then it should be rejected, and so on and so forth. So you can create this on an even higher abstraction level than we had before, to even, human language, what I wrote into the comments before, right? And then you can say, okay, take this test, this Cucumber test. I actually was running it before the whole time, so we could run it again. And then have some step definitions to say, okay, order should be accepted, should be rejected, or here, create an order with this and that. What does it actually mean? So what do I do here, right? And then if you now look at the code, this is very similar to what I had in my test code. Actually, it even uses the same system, and then I can do this as well. So this, sometimes it was helpful to just non-technical domain experts who did not, want to write Java or something like that, but they defined, scenarios like this, or for testers, this can be helpful. On the other hand, I also had actually testers and non-technical folks who were totally fine with reading such code, right? Because if you write it on a nice abstraction level, you don't even have to know Java, right? Imagine if you don't know Java, or maybe you don't. You say, okay, coffee order system dot create order, brackets, another bracket, semicolon. You probably will wonder about the weird bracket and the semicolon, but if you ignore it, you say, okay, coffee order system, create order, espresso, Colombia, right? So, well, it will probably create an order from espresso in Colombia. So if you know about the coffee domain, if you know what order is, what espresso is, what Colombia is, then you understand what's going on. And this is also very readable. So, from my experience, there's many times this was just fine to present nicely readable Java code and say, okay, what are the test scenarios, and can we create new ones, and can we change some details here? So that's the other aspect of that. It depends what you're doing there, but for me, these are the most important, somewhat takeaways. Yes, and that's basically most important things I have here. So already want to say spasiba and thank you for the attention. You can get all of the code if you just follow the first link and all of the extra resources. And now I want to have a chat with our expert and also cover the polls that we did and answer the remaining questions.
Yes, we have a question. Question from Anton. Anton told that the hipster tool, they work with it, and the hipster generated a test class with Spring test class, and
yes. So I haven't.
Yes, and about Carcass, is it the same approach, or we need to write our tests from the start?
Okay, so I don't know too much about what type of tests JHipster generate. I'm aware of JHipster. I have not used it myself because I didn't need the extra connection, and I'm mostly more on the enterprise Java side than on the Spring side. So I'm not quite aware of what type of test they generate, but I can tell you what the Quarkus tests do, which is, I would say the Quarkus tests are a little bit more similar to Spring context tests, or actually very similar. They also start up your application. So this is basically this one, a Quarkus test, and then it starts up a Quarkus here. And you can, like I showed before in the code, you can inject your classes here. So this doesn't generate code for you. It basically creates the application context that you say, I have the CDI context available, and I can inject my test. But I think the way how the question is formed, probably JHipster creates a little bit more on top of, creates some actual test code, generates test code. So I don't know what JHipster does here. But in general, whatever it creates, I just claim you have to know your domain, right? But basically what you do with all of these components, you abstract some business functionality, right? So if the project already creates some, predefined classes for your production classes, then that's fine. That's a nice starting point, I think. But basically what you say, okay, I want to have an abstraction, something like is system up, and then just a Boolean, right? Not the lower level details. I don't care about that. And the same with the code level tests. If I say, okay, verify the coffee order creation and things like that, where is it? With my use case test and my test double to say, verify create order, and then you have to do the lower level verification, and you have to create this once, right? I claim you can hardly just generate it because you have to know what you do on the business logic, what you're actually invoking. But other than that, I'm sorry, I cannot speak much for this JHipster kind of their generation because I haven't used this.
Okay, thank you, Sebastian. Also, we have a question from Dmitry. I will read it. Often you need to mock different services in different order, and every test should be run on the CI/CD server on prod-like environment. What do you recommend it? For me, it's an unclear question.
Yeah, I also don't know what the question exactly or what I recommend. So what I showed here, this was just an example for the workflows. What you do in a local development really depends which feature you're working on right now, right? So if you say, okay, I'm just working on an algorithm that uses a single class that has a highly dense logic that I can test in a unit test or in a code level test, then I only use this phase, or not even the build. I say, okay, I just stay in my IDE, I write my code, and then I run my test in the IDE, right? Then you don't really have this pipeline here or this chain. Typically what I do in like microservice environment, that you have at least, like these type of ranges where you say deploy something locally, deploy it once in the morning, keep it running for a while, and then just, test, redeploy, this hot swap redeploy, rerun your test, change code, rerun your test, and then if you have, so on. And then if you have an environment where you say you need to verify a third system or a database, where you actually build up a whole system test environment that includes more components, then you're just a little bit more on the right side of this. But basically, it really depends what you do locally. For a CI/CD pipeline, it's easy because the pipeline always runs the thing, from beginning to the end, and it just stops if it fails somewhere. So it will deploy to test environment first, and do the smoke test, do the system test, and then you can continue it here of saying, okay, actually, if this already worked, then I go and deploy it again to a different environment, like staging environment or even production, and say, like now you have a proper testing suite and you just extend it, right? If you say the system tests, you can already reuse the same tests, and then you have maybe other system tests that don't involve the mocked barista, but the actual barista, right? So you can swap out this logic and then you configure it differently. And then you already have so much confidence that at the end you say, okay, now we do continuous deployment, and then we actually directly deploy to production. So then, this is the extension to the pipeline until the end. But for local development, I would say, like you usually have some variation of some steps like here. That's what I would answer.
Yep.
We have some questions.
Sorry, do you hear me?
Now I hear you.
Yeah.
Great, guys. So we are on a final line. Just one question with a quick answer, if possible. Sebastian, what model of motorcycle do you have?
That's a very good question. Actually, right now, I don't have a motorcycle anymore. I used to have two motorcycles. One is a Kawasaki Ninja, one of these green Japanese racing bikes. I really enjoyed that. And the second one that I had was a more relaxed one. It was a Triumph Adventurer for, like more relaxed riding. The reason why I don't have a motorcycle anymore is that, before Corona, I traveled a lot and I didn't really have time to ride at home. So I sometimes rented a motorcycle on the road, like we did in Japan with some tour. And then I said, okay, it doesn't make sense to own a motorcycle.
Sorry, Sebastian, I should interrupt you because we are on time already. So you could continue in discussion zone by a Zoom link that will be provided. Please choose the best answer in discussion zone, and we will give a prize to that guy. So thank you, and we are going to our advertisement. Thanks, Sebastian. See you. Thanks, Artyom.
Thank you.